I am Fazil Akhtar. Today I am here to present a demo on the topic chemical equilibrium. Chemical equilibrium. Before we will discuss the concept of chemical equilibrium, I will discuss some important concepts like chemical reaction. Chemical reaction. What is chemical reaction? Basically, it is the symbolical representation of any chemical change in terms of reactants and products. Symbolical representation of any chemical change, any chemical change in terms of reactant and product. So this is the chemical reaction, symbolical representation of any chemical change in terms of reactants and products. Types of chemical reaction. Types of chemical reaction. Chemical reaction. First one is on the basis of physical state. On the basis of physical state. Physical state. It is of two types. First is A point is homogeneous reaction. Homogeneous reaction. In homogeneous reaction, the reactants and products are in same phase. Reactants and products are in same phase. Same phase. This is the basic concept. For example, N2 gas plus 3H2 gas gives 2NH3 gas. So here the reactants are in same phase like gaseous phase and the product is also in same phase like gaseous phase. So reactants and products are in same phase. So this is all about the homogeneous reaction. Come to next B point, heterogeneous reaction. Heterogeneous reaction. In heterogeneous reaction, the reactants and products are in two or more phases. Reactants and products are in two or more phases. More phases. For example, zinc solid reacts with CO2 gas. It gives zinc oxide solid plus carbon monoxide gas. So the reactants and products are in two or more phases. Come to next point, on the basis of speed. On the basis of speed. On the basis of speed, A point is fast reaction. Fast reaction. It is also called ionic reaction. Ionic reaction. Like acid, HCl acid reacts with base NaOH base. It gives salt NaCl salt plus water H2O. So this is the fast reaction, also called ionic reaction. B point is slow reaction. Slow reaction, also called molecular reaction. Molecular reaction. For example, CaCO3 gives CaO plus CO2. So this is the molecular reaction. B point, endothermic reaction. Endothermic reaction. In endothermic reaction, change in enthalpy delta H is positive, or we can say that absorbed. Heat absorbed. For example, CaCO3 gives CaO plus CO2. Come to next point, on the basis of direction. On the basis of direction. It is of two types. First one is reversible reaction. Reversible reaction. For example, HCl plus NH4OH gives NH4Cl plus H2O. The reaction proceed in both direction, in forward direction or in backward direction. So it is the reversible reaction. And the next one is irreversible reaction. Irreversible reaction. The reaction proceed only in one direction. For example, AgNO3 plus NaCl gives AgCl in the form of PPT and forms NaNO3. So this is all about the irreversible reaction which is proceed only in one direction. Come to next point, equilibrium and chemical process. Equilibrium and chemical process. Consider a chemical reaction in closed vessel. For example, AA plus PB gives CC plus DD. Here a, small b, small c and small d are their stoichiometric coefficient. If we calculate the equilibrium constant in terms of active mass, so the formula becomes C to the power C, D to the power D upon A to the power A, B to the power B. In terms of active mass. In terms of active mass. So equilibrium constant Kc is concentration C to the power concentration C, D to the power concentration D divided by A to the power concentration of A, concentration of B to the power B. So if we calculate Kp in terms of partial pressure, it becomes Pc to the power C, Pd to the power D divided by Pa to the power A and Pb to the power B. So this is in terms of partial pressure. In terms of partial pressure. In terms of mole fraction, it is Kx. X C to the power C, X D to the power D, X A to the power A and X B to the power B. So in this reaction, if we move to forward reaction, then their rate is Rf, and if we move in the backward direction, then its rate is Rb. So in equilibrium state, rate of forward reaction is equal to rate of backward reaction. It is at the equilibrium state at which their rates are equal at a particular concentration. This is equal to Kf upon Kb. Rate of equilibrium constant at forward reaction, equilibrium constant at backward reaction. Equilibrium is dynamic in nature. Equilibrium is dynamic in nature. Equilibrium approaches from both sides. Equilibrium approaches from both sides, either from right side or from left side. Concentration of reactant and product, concentration of reactant and product do not change with time. Do not change with time. Equilibrium can be attained. Equilibrium can be attained both in heterogeneous and homogeneous system. Both in heterogeneous and homogeneous system. First is homogeneous equilibrium. Homogeneous equilibrium. In homogeneous equilibrium, reactants and products are in same phase. For example, there is a ester CH3COO C2H5 liquid reacts with H2O liquid. It gives acetic acid CH3COOH in liquid form plus ethanol C2H5OH again in liquid form. So in homogeneous reaction, reactants are in liquid phase, products are also in liquid phase. So the phases are same in the homogeneous equilibrium. Come to next point, heterogeneous equilibrium. Heterogeneous equilibrium. In heterogeneous equilibrium, reactants and products are in two or more phases. For example, zinc solid react with CO2 gas, it gives ZNO solid plus carbon monoxide gas. Thank you so much, students.